All right, class. Today, because I'm on travel to participate AI Day for local schools, and then I will have to record a video for Tuesday's class. And the topic we'll cover is algorithm chains and pipelines. So we know that machine learning applications require not only a single model. It's often the case that required many processing steps, like you rescale the data, or you enlarge the data, or you reduced the data. And then you feed into a machine learning model. So today we'll learn how to use a pipeline, which is a class in sklearn, to combine data processing and models. Second, we'll learn how to combine pipeline and then grid search CV, which we have learned in last lecture, and to search over parameters for all processing steps. Okay, so sklearn provide library transformers which may clean, reduce, expand, or generate feature representations. And then after this processing, transformer processing, and then we can feed the data into estimator, and then put them together, combine them together, we have a machine learning system. In sklearn, it uses a pipeline function called pipeline to combine the transformers classifiers. Okay, the general pipeline interface look like that. So we'll use a class. It's called pipeline, and the key input parameter is called step. So step will be a list. It's a list of name, the name we assigned to the transformer, and then the transformer name. So, and if we call the transformer and estimator, so we will have estimator 1 will do transformation, and then we could add more transformers. So estimator 2, we call the function transform, and until that we reach the last estimator, and the last estimator must have a fit function. Then we can use it to fit the data. Okay, that's the general pipeline interface. And we will use the example to show that how to use it. And the data set we'll use is cancer data. And what we'll do is we will use a minimum maximum scaler to rescale the data, and then we use a SVM to do a machine learning model. All right, now we go to Anaconda. So we'll use Jupyter Node, and we'll create a new Python code. Here, first step, we will import dataset. So the dataset we'll use is a breast cancer, and we'll from sklearn.dataset import load, and we'll load breast cancer. Will generate a cancer object named as cancer, and then call this function. After that, cancer will be a dictionary-like data, and in which it has the data and target, and also target names, feature names. Here what we need is we can have before we load the data into X and Y, we take a look at this general description of the model, cancer dot description, and give us the information of the data set. So we have 569 samples, and each sample has 30 attributes or features, and that's attribute information. And the class has two classification. One is malignant or benign. So two classifications to label cancer. And they'll also tell us statistical information about each feature. And the key observation is if you see the minimum maximum, so the data for each feature spans from like point decimal number, small decimal number, until that very big number up to 2,000. So that means if we use SVM, we need scaled data. Or we use machine learning, we also need, if we use neural network, we also need rescaled data. So that's provide an example that we can use pipeline to connect scaling, data scaling, and machine learning model. All right, now we have the data. What we'll do is we'll get the data, all the features in uppercase X, and the target we'll put in Y. And then we'll split the data into training and test. So we will use from sklearn dot datasets. No, not datasets. So it's a model selection. Import train test split, and then we can split the data. So we have X train, X test, Y train, and Y test. And then we call the function train test split. We'll split X, Y, and by default it's 20%. We'll split into testing. So we'll use the default value, and the random state will use 0. And we write, and then we should have train and test data. So after that, we will create our model, and with both scaling and machine learning. To do that, we need import a scalar and also machine learning model from sklearn dot preprocessing. So import, let's see that we just import a very simple scalar main maximum. So we rescale the data into a region from 0 to 1. And the machine learning model we'll use is SVM, because we use SVM because as preprocessing, rescaling data is a prerequisite for SVM. Classifier, because this is a classification problem, and we need pipeline. So we'll use sklearn dot pipeline, import pipeline, and then we generate a pipeline object. Inside, we need set a parameter, which is a list with different steps. Like step 1, we want to rescale it, so you can name it. I will name the first step as scale. You can name this. You can name it the scale or scale 1 or S1, whatever. That's the you decide how to name it. And but the scalar we'll use as a minimum max. And then you can name the machine learning model. I will call it SVM. Again, this is a name you can change. And then we'll use SVM classifier. And you can set another parameter called verbals. And if you set it true, it will show the step when you train the model. Now we have the pipe, and then now we have the pipe is a combination of scaling and the machine learning model, and then we can use it to fit into the data. No, Y train. You can write, And to show that it's very fast, so we have step 1, step 2, take very short period of time, and then first step is scale, second step is SVM, and then we have this model. After we have this model, we can take a look at pipe. We can look at the wait. So we can now what we have trained is on the X train, Y train data, right? So we can look at its performance in test data. So what we can do is pipe the dot. Can either use predict or directly use score to calculate the score for the test data. All right, and then that's the performance on the test data. Okay, that's how we can use pipe to do the job, the pipeline to do the job, to combine different steps. And another thing we want further explore is we can combine pipeline as well as grid search. So to find best parameter to tune the parameter of our models, and then to find the best performance machine learning model. So, and the example showed here is, again, we'll still use the scalar, and we'll also use SVM, but this time we'll explore the space in SVM. We know that for a nonlinear SVM, we can the two parameters we can tune. One is C, the other one is gamma. Gamma is for the kernel. C is for the regularization, or the inversely proportional to the regularization. That is the uppercase C. So let's do it in Jupyter Note, and when we do it, I will explain the details. So, and then we still use the data, the data set we have, and what we need more is from sklearn a model selection, we import grid search, and cross-validation grid search. So let's see, we have a grid search. We'll call it a grid search. And what we'll do is we'll input a pipeline, and then we input the parameter grid, and we'll name it variable grid, and CV cross-validation will use 5-fold cross-validation, and then we'll use parameter grid to define the parameter we'll search, and which is dictionary-like. So, and we'll search scale. Remember, the scale is for minimum maximum scalar. So for the scale, we don't need to parameter search, so I will skip that. And parameter will search this in SVM, because we name it as SVM. Here we name it as SVM, and then we'll use SVM and then double underscore again. SVM double underscore. So I put SVM double underscore, and followed by parameter, we will adjust the hyperparameter will tune. So double underscores. There are two hyperparameters for SVM. So SVMC, and then parameter will tune as C, and we'll use the log space, start from 0.01, 0.11, and then 10. or we can do 100. All right. And this is a dictionary like, so each k so we have two k's, c and gamma, each k, and we'll generate a parameter list for the model to search over. Right, now we have that, so we do grid search. Let's write first, and then later we'll use grid search. Now we have the model, we'll fit into X train and Y train. And it will show the search process because it's search each pair of parameter and take some time. And then we have it. If you don't want to show this pipeline steps, you can set as a verbose parameter in pipeline as false. So now we have this model, and know that there's so many parameters, and we want to look at the best parameter we have, and we also take a look at the best score, and the best score for the training data is 0.981, and the parameter corresponding parameter, so c equals 1, gamma equals 1. Again, so we still need to do the test. This is our training data set, and then we can do the test on the testing data. And that's not surprised because the best parameter defined is 1, 1, and the testing data is 97.2%. And we have the same accuracy for the test data as we have done in previous model. All right, that's this part. So another thing I want to show you is, so there's an alternative way to use pipeline. Is a user function called a make pipeline. So if you use a make pipeline, then you don't need to name the scalar or the model you will use. So, and for example, and this example shows here is instead of using pipeline, it use make pipeline, and then you don't need to name the scalar or the classifier as we see here. Just use their class names, and later, and then when you use grid search cross validation, the parameter grid, it will use is a lowercase classification name, class name. For example, SVC, the lowercase SVC will refer to the classifier SVC, and the lowercase min max scalar will refer to the scalar class, and then the rest will be the same. Okay, so now, and we'll use this idea to work on a problem we have came across before. Remember that in SVM modeling, develop machine SVM modeling from scratch, we deal with a problem, nonlinear problem. We have data set, we call it make circles. We have 2 circles data, and the decision boundary would be a circle, so it's non-linear. So if we use a linear model to work on this, it won't work. However, so there's one way we can overcome this. We can still use a linear model if we augment data. So right now we only have 2 features. If we can augment the data into more features, and then more feature introduced is the higher order of feature 1, feature 2, and then that will make the problem make the problem into a nonlinear. We have nonlinear features, then we can use a logistic regression model to work it out. Right, so to do that, what we'll do is we will use polynomial features, the first class, which will augment our only two features into multiple features, and we can tell the polynomial feature that what the degree, like high order degree, second degree, third degree, or fourth degree, and so on. And then after that we'll use logistic regression model to work on it. And then we also need make pipeline and also grid search CV to work it out. Okay, so now we'll go to Jupyter Note here, and then we will work on it. So again, first step, we'll create the data. And this time, the data is 2 circle. And we need from sklearn dataset import make circles, and we'll have x, y equals make circles, and the number of samples we'll use 100, and factors was the ratio of 2 circles. I'll set it as 0.5, and the noise, we'll put some noise, and then we'll put a small noise there, and then we set the random stage 0, and then we will have XY data. So now we have XY data set. We can take a quick look at that. And import matplotlib pyplot as plt, and then we can plt scatter the data, because this is 2D, so we can visualize it. The first feature, second feature, uppercase X, and then color will be its classification. Now that's the data set. We have 2 features, and the color represents classification. And then we'll use the pipeline to combine a polynomial feature augment plus a logistic regression model, which is a linear model. Right. So to do that, we need first from sklearn will import polynomial features, and we'll also need logistic regression, which is in linear model. Logistic regression, and this time we will use pipeline, make pipe function. Instead of using pipeline, there's an alternative method. Sklearn pipeline import a function called make pipeline, and we'll use make pipeline to generate a pipeline polynomial, and then logistic regression. Again, we can set variables to true, then we'll see the each step. And then now we have the pipeline, and then we can create a grid search object. Grid search will be a machine learning model combined grid search CV. We'll have pipeline, and we'll do a parameter search. Parameter grid will be, I'll also name it as parameter grid, which will set before this line. We'll do it later. And CV cross validation will set as 5 5-fold. And now we define the parameter greet, because again that will be a dictionary, and we will have two keys. The first key is a polynomial. So the make pipeline will not allow to assign names for each step. Instead, it will use a lowercase class name to represent the step name. So we'll use exactly polynomial features, but instead of using uppercase, we use a lowercase. Double underscores, and then set a parameter. The degree is an input parameter for polynomial features, and we can set as to different degrees. So we can set as 1, 2, 3, 4, 5. And then let's just take regression. Be careful. So you have to make it exactly the same as let's take a regression class with all lowercases, and then add 2 double underscores. The parameter we can change as C, hyperparameter C in logistic regression, which we can set as 0.01, 0.1, 1, and 10. Alright, and then we have this model. Okay, right. After that, we can feed data. Now we only have XY. I will not split it to make it simple. And this is a training process. Now we have the model, and then we can look at that. Model name we call it grid search. We can look at the best estimator, best score, best parameter. Do best parameter we have. So the best parameter is a logistic regression 1, and the polynomial degree is 2. Let's look at best training score. Best training score is 1. And we can look at cross-validation result. It's mean test scores for all combination of hyperparameters. And that's what we have. Or we can reshape it into 2D. Let's see. So 1 is 4 is 5, and that's what we have. Guess we should go with 5, and that's the right way to present it. So each column, I guess each column should be polynomial degree, and then logistic regression C for one is a C, what the other one is a degree for polynomial features. Okay, now back to our slides. Well, grid search can do even more. So for example, you can even go further in combining grid search CV and pipeline, and not only rescale the data, and you can also choose which scalar you want to use, and you can also compare different classifiers. Like in this case, in this slide, it shows that random forest and SVC, so SVM classifier. So this leads to even bigger search space, not just hyperparameters in each step. It's also each step you can choose different models and scalars. Okay, so I will leave after class problem. So use the grid search method in previous slides, which is slide 9, to work on the Cantor dataset, and then to find the best combination of scalar and also classifier. All right, then we'll stop here for today, and we'll see you on Thursday.